Good morning, students. Exercise 7.6, first problem, third subdivision. That is, the problem is regarding to find absolute maximum and minimum value. So, what is the procedure to find absolute maximum and minimum? The first step, you have to find the critical number. So, critical number or critical point at which f dash of x is equal to 0 or f dash of x does not exist. So, first step, you have to find the critical number and you have to check whether the critical numbers belong to the interval given. Okay, then n points of the intervals and the critical number has to be substituted in f of x. Among these values, which is the largest one, that is called the absolute maximum, and which is the least one, that is called the absolute minimum. Okay, you come to exercise 7.6, first problem, third subdivision. F of x is equal to 6x power 4 by 3 minus 3x power 1 by 3. The given interval, closed interval, minus 1 to 1. Okay, first step, we are going to find the critical number. For that, you are going to find the f dash of x. So, see now, 6 is a constant. Here you are having x power 4 by 3. Using power rule, you have to differentiate this. So, it is 4 by 3, x power 4 by 3 minus 1. Go to the second term, minus 3 is a constant. X power 1 by 3. Using power rule, how it has to be differentiated? 1 by 3, x power 1 by 3 minus 1. So, see now 3 and 6 getting cancelled. So, here you are having 2 4s are 8. So, 8 x power. Take LCM. So, it will be 3. So, 4 minus 3 divided by 3. So, that is 1 by 3. And this 3 and here 3 getting cancel. So, here you are having x to the power. If you take LCM, it is 3 is the LCM. So, 1 minus 3. So, 1 minus 3 is minus 2 by 3. So, from these two terms, we have taken x power minus 2 by 3 is outside. Okay. So, here what is remaining? 8. So, from this, if you have taken x power minus 2 by 3 out, the remaining is x. Just multiply these two. What it is? X power minus 2 by 3 into x power 1. Okay. So, if you simplify, what will you get? X power minus 2 by 3 plus 1. So, if you take LCM is 3. So, minus 2 plus 3 has to come. So, minus 2 plus 3 is 1. So, it is x power 1 by 3. So, from x power 1 by 3, if you take x power minus 2 by 3 is outside, the remaining is x. Okay. So, here you will have this term, whole term is taken out. So, here you will have minus 1. So, this is your f dash of x. So, f dash of x is equal to 8x minus 1 divided by, so you have to bring this term to the denominator. So, here you are having minus. When it is brought to the denominator, it will become plus. See, if you substitute x as 0, the denominator will become 0. So, therefore, f dash of x does not exist. So, when x equal to 0, your f dash of x does not exist. And f dash of x is equal to 0 implies the whole term is equal to 0. So, the denominator into 0 is 0. So, 8x minus 1 is equal to 0. X is equal to 1 by 8. So, x equal to 1 by 8 and x equal to 0, both are critical numbers or critical points. So, critical points or the points at which f dash of x is equal to 0 or f dash of x does not exist. Okay. So, see that these 2 points you have to check whether they belong to the given closed interval. So, see that 1 by 8 and 0. So, both belongs to the closed interval minus 1 comma 1. Okay. What's the next step? you have to substitute the end points of the interval and the critical numbers in f of x. So I'll take the first end point -1. So I'm going to substitute here f of x. So f of -1 is equal to 6 into -1 the whole power 4 by 3 minus 3 into -1 the whole power 1 by 3. So this can be written as -1 the whole power 1 by 3 to the power 4 minus 3 into -1 the whole power 1 by 3. So if you calculate, you will have three values. One of the value is -1, the other two values are imaginary. So here we will take -1. So -1 the whole power 4 is +1. So 6 into 1, it is 6. Okay, next one. Here -1 the whole power 1 by 3 is -1. So it is 6 plus 3, that is equal to 9. Next, f of 1. So f of 1. So f of 1, so it is 6 into 1 to the power 4 by 3 minus 3 into 1 to the power 1 by 3. So it will become 1 to the power 4 by 3 is 1. So it is 6 minus 3, that is equal to 3. Next, f of 0. So 0 has to be substituted in f of x. So your f of x is what? 6 x power 4 by 3 minus 3 into x power 1 by 3. So when you substitute x as 0, so the whole term will become 0. So you will get the answer as 0. Next, f of 1 by 8. So 6 into 1 by 8 the whole power 4 by 3 minus 3 into 1 by 8 the whole power 1 by 3. This 1 by 8 can be written as 1 by 2 the whole cube to the power 4 by 3 and minus 3 into 1 by 8 can be written as 1 by 2 the whole power 3, the whole to the power 1 by 3. So this 3 and here 1 by 3 getting cancelled. So you will have 1 by 2 the whole power 4 minus 3 into, the same way the power getting cancelled, here you will have 1 by 2. So 6 into 1 power 4 is 1, 2 power 4 is 16. Minus 3 into 1 by 2 is 3 by 2. So here you will have, when you simplify, it is 3 by 8 minus 3 by 2. So when you take LCM, your LCM is 8. So here you will have 3 minus 12. So what is it? Minus 9 by 8. See what are the values you are getting? 9, 3, 0 and minus 9 by 8. Among these values, which is the greatest one? That is 9. So this is the absolute maximum is 9. So which is the least one? The negative value is the least one. So this is the absolute minima. So here I have written, see that absolute maximum is 9 and absolute minimum is minus 9 by 8. Come to the fourth subdivision. F of x is equal to 2 cos x plus sin 2x in the closed interval 0, pi by 2. So first step, what you have to do? You have to take f of x and you have to differentiate. So see that 2 is a constant. What is the differentiation of cos x? Minus sin x plus sin 2x. How to differentiate? Using chain rule. So this 2x has to be kept as x. So it is in the form of sin x. So sin x differentiation is cos x. So in the place of x you have to write 2x. So cos 2x. After that, which is kept as x, that has to be differentiated. So 2x is kept as x. So when you differentiate 2x, it is 2. So you are getting minus 2 sin x plus 2 cos 2x. So one term is in sin, another term is in cos. So we have to change using the trigonometry formula. Cos 2x can be written as 1 minus 2 sin squared x. So when you multiply this 2 with the two terms, it is 2 into 1 is 2, 2 into minus 2 sin squared x is minus 4 sin squared x. So you are going to find the critical number. So for that, f dash of x is equal to 0. So minus 4 sin squared x minus 2 sin x plus 2 is equal to 0. Divided by minus 2, here you will have 2 sin squared x plus sin x minus 1 is equal to 0. It's a quadratic equation in terms of sin x. So 2 into minus 1, what do you have to get? Minus 2. The product of two terms should be minus 2 and the addition is 1. Okay, so I'll take 2 into minus 1. 2 into minus 1, when you take the product, it is minus 2. When you add, it is 1. And here you see that here your a is 2. So it has to be divided by 2. So 2 by 2 is 1. So here sin x plus 1 and 2 sin x minus 1 is equal to 0. Because this quadratic equation involving sin x. So instead of x, you have to write sin x plus 1. And 2 sin x minus 1 is equal to 0. Take the first term, sin x plus 1 is equal to 0 means sin x is equal to minus 1. So, minus 1, it's a negative. So, this can be written as, what is it? Sine of minus pi by 2. Minus 1 is, we can write as sine of minus pi by 2. So, x is equal to minus pi by 2. It does not belong to the closed interval 0, pi by 2. 0, pi by 2 lies in the first quadrant. So, therefore, all should be positive. So, it is not possible. Okay, for this interval. Okay, so next term you consider 2 sin x minus 1 is equal to 0. 2 sin x is equal to 1. Sin x is equal to 1 by 2. So, 1 by 2 can be written as sin pi by 6. That is sin 30 degree. So, x is equal to 30 degree. Your 30 degree lies in this interval 0 to 90 degree. So, we will take the critical number x is equal to pi by 6. And what are the results you have to take? The n points of the interval. So, you have to take 0, pi by 2 and the critical number pi by 6. All the three numbers has to be substituted in f of x. You see that the substitution. First f of 0. So, when you substitute, it is 2 cos 0 plus sin 0. Cos 0 is 1. So, 2 into 1 is 2. Sin 0 is 0. So, the answer is 2. Next end point pi by 2. When you substitute 2 cos pi by 2 plus sin 2 into pi by 2. So, cos pi by 2 is 0. Here 2 getting cancelled. Sin pi, that also 0. So, f of pi by 2 is equal to 0. Next, the critical number pi by 6. When you substitute 2 cos pi by 6 plus sin 2 pi by 6. Okay, 2 into, what is it? Cos 30 degree. That is root 3 by 2. And this 2 and 6 getting cancelled. Sin pi by 3. So, sin, what is it? Sin 60 degree. That is root 3 by 2. Okay, so here root 3 plus root 3 by 2. If you take LCM, it is 3 root 3 by 2. Okay, so you will have the values 2, 0, 3 root 3 by 2. So, we have to find out among these values which is the greatest one. For that, I have done the calculation. You see that 3 into root 3 is 1.732 divided by 2. It is approximately 2.598. Here you are having 2. Here you are having 2.598. So, therefore, which is the maximum value? This is the maximum value, absolute maximum, and 0 is the absolute minimum. So, we have completed the problems in absolute maximum and minimum. So, we are moving to the next topic, relative maximum and minimum. So, that is called relative extrema on an interval. So, instead of relative extrema, we can say local extrema, that is local maximum minimum on an interval. See the graph y is equal to f of x, simply I have drawn it. You see these 2 points. What happened to these 2 points? These points at which the function attains maximum. Okay, among these 2 maximum points, this point is the largest one, highest value it has. Your f of x has highest value. So, in the entire domain, okay, this is the absolute maximum value for the function. And what about this? This also maximum value in the given interval only. Okay, not in the entire domain. So, in the given open interval, this is called the maximum value. So, that value is called relative maximum value or local maximum value. Okay, see the definition now. A function f of x is said to have relative maximum. What's the word? Relative maximum or local maximum we can say at x naught. So you take, this is the x naught, the x value is x naught. Okay, so a function f of x is said to have a relative maximum at x naught if there is an open interval containing x naught on which f of x naught is the largest value. So in this open interval containing x naught or at which this is the maximum value. So on the whole entire domain, the largest value is called the absolute maximum. So in the open interval, so small interval if you consider, in that interval, so the point the function attains maximum, that point is called the local maximum or relative maximum. So see these 3 points in the graph. So at these points the function attains minimum. Okay, so among these 3 points, this point is called the absolute minimum value. Okay, so these two are nothing but local minimum or relative minimum. Okay, so in this open interval, if you consider from here to here, this is the minimum value. So when you consider in this open interval, so this is the minimum value. So in the whole entire domain is considered, this is the lowest value for the function. So this is called the absolute minimum value. So see that the definition, f of x is said to have a relative minimum at x naught if there is an open interval containing x naught on which f of x naught is the smallest value. So while you are talking about relative extremum or local extremum, we have to consider the open interval containing the point on which f for that value of the function is smallest or largest. Okay, see the relative extrema, that is local maximum, local minimum, need not be the largest value or the smallest value in the entire domain. While you are talking about relative maximum means that value need not be the largest value in the entire domain. Okay, so we will have, there may be more than one relative maximum or relative minimum on the entire domain. Okay, we will go to the Fermat's theorem. F of x has a relative extrema. Extrema means both extreme, that is maximum, minimum at x is equal to c. So x equal to c la and the function relative extremum kedachadu appdin sonna, then c is a critical number. So critical number means at that number f dash of x is equal to 0 or f dash of x does not exist. That is called the Fermat's theorem. Okay, so using how to find relative extrema using two tests. One is using first derivative test we can find it, or using second derivative test we can find the relative maximum and minimum. Now we are going to see the using first derivative test how to find the relative maximum minimum or local maximum minimum. Okay, so for that exercise 7.6 I am moving to the second problem. Find the intervals of monotonicities and hence find the local extremum for the following functions. So two things are asked. One is you have to say about the monotonicity of the function. That means in what are the intervals the function is increasing and the function is decreasing. So you have to mention that first. Second one, you have to find the local extremum. What is local extremum means? It is at what interval or at what points you are getting the function is the function attains local maximum or local minimum. You see the procedure. So I'll consider the function. So whatever it is, you have to find the first derivative. That means you have to differentiate the function. So take 2 is a constant and x cube if you differentiate it is 3x squared plus 3 is a constant. When you differentiate x squared, it is 2x. And minus 12x, if you differentiate, it is minus 12. So, f dash of x is equal to 6x squared plus 6x minus 12. So, what's the second step? F dash of x is equal to 0. So, 6x squared plus 6x minus 12 is equal to 0. So, when it is divided by 6, it is x squared plus x minus 2 is equal to 0. Just factorize this quadratic equation. So, you will have x minus 1, x plus 2 is equal to 0. You are getting x is equal to 1 and x is equal to minus 2. So, the intervals are, so you have to write the intervals starting from minus infinity to plus infinity. So, first you have to arrange the points in the ascending order. Okay. So, it is first one, what has to come? Minus 2. The second one is 1. So, you have to start from minus infinity to minus 2, minus 2 to 1 and 1 to infinity. So, here you have to write the intervals, then sine of x minus 1. Why we have to write x minus 1? So, f dash of x has to be considered. So, this can be factorized and you are getting x minus 1, x plus 2 into 6 because 6 is common. So, this can be written as your f dash of x can be written as, it can be written as 6 into x minus 1 into x plus 2. So, for that, here we are going to check the sine of x minus 1. Next factor sine of x plus 2. Then you are going to check the sine of f dash of x, that is 6 into x minus 1 x plus 2. And you are going to write the monotonicity. Okay. So, what are the intervals here we have found? That is minus infinity to minus 2, minus 2 to 1 and 1 to infinity. So, you consider the first interval minus infinity to minus 2. So, in this interval you consider a point. So, shall we have minus 3. So, when you substitute minus 3 here, minus 3 minus 1 is, what is it? Minus 4. You need not find the value. You have to check whether it is negative or positive. So, here it is negative. So, minus 3 plus 2, what has to come? It is negative. So, here I have written the product of these two. So, minus into minus is plus and here 6 also plus. So, the whole term it is plus. Your f dash of x is plus. That means your f dash of x is greater than 0. So, in the previous class we have seen your f dash of x is greater than 0. The function is strictly increasing. So, here I have written strictly increasing. Okay, take the next interval minus 2 to 1. So, it's a negative number. This is a positive number. So, we can have 0. So, when you take 0, it is negative. When you take 0 here, it is positive. So, here the product of these two with 6. So, minus into plus is minus. Okay. So, your f dash of x, how it is? It is negative. So, negative means what it is? Less than 0. If f dash of x less than 0, in this interval, the function is strictly decreasing. Okay, consider the next interval 1 to infinity. 1 to infinity, we can take 2. So, 2 minus 1. So, it is positive. And 2 plus 2 is 4. That also positive. And when you take the product of the positive into positive is positive into 6 also positive. So, your f dash of x positive means it is greater than 0. So, f dash of x greater than 0, this is strictly increasing. So, here we have decided about in what are the intervals the function is increasing or decreasing. You see that in these open intervals the function strictly increasing. So, f of x strictly increasing on minus infinity to minus 2 and 1 to infinity, and it is strictly decreasing on minus 2 comma 1. So, the first question, first we have found the intervals of monotonicity. Next, what is asked? You have to find the local extremum. You see the curve, local extremum. While I am talking, I have used this curve, isn't it? Okay. See this. Here the function is increasing, isn't it? If the function is increasing, your f dash of x, how it should be? Your f dash of x is greater than 0, isn't it? So come to this side. How it is? The function is decreasing. So your f dash of x, how it will be? It is less than 0. You see that? So here it is positive. F dash of x is positive. This side f dash of x is negative. So when f dash of x changes from positive to negative, what you are getting? You are getting a maximum value. Okay. Come to now, for example, here it's a decreasing function. So your f dash of x, how it is? It is less than 0. And here it is a increasing. So your f dash of x is greater than 0, isn't it? Okay. So here negative to positive comes, you will get a minimum point. You see that? F dash of x changes from positive to negative. Positive to negative, the function attains maximum. F dash of x changes negative to positive, the function attains minimum. Okay, that result only we are going to use to find local maximum, local minimum. You see this interval, your f dash of x, what it is? It is positive. Next it changes to negative. So f dash of x changes from positive to negative when passing through which point? -2. So therefore positive to negative comes, the function has local maximum at x is equal to -2. Okay, so what we have? We located when x is equal to -2, the function attains local maximum. Next we are trying to find the local maximum value. X value is here, you are going to find the y value. So what is y? Y is equal to f of x. So this -2 has to be substituted in your problem, f of x. Okay, what is your f of x? This is your f of x. So here in the place of x, you have to substitute -2. So I have substituted here. So the result is -16 plus 12 plus 24. That is 20. So the local maximum value is 20, which is obtained at x is equal to -2. And okay. And you just consider the second and the third interval. So here your f dash of x changes negative to positive. Negative to positive comes when passing through x is equal to 1. Okay, so you will obtain minimum. So see that since f dash of x changes from negative to positive when passing through x is equal to 1. So f of x has local minimum at x is equal to 1. So we located at what value of x we are getting local minimum. Then you are going to find the local minimum value. That means x is equal to 1 has to be substituted in f of x. So when I substitute, I am getting the value -7. So this is the local minimum. It is obtained at x is equal to 1. Okay, thank you students.